Hello friends, today we are going to solve one numerical. Two charges Q1 and Q2 are present on two bodies certain distance apart. A charge small q is transferred from one body to another so that electric force between charges become maximum. What is charge left on each body? Students, note that in this question you are given two charges Q1 and Q2. You are not given the distance between the charges. This distance is unknown. And then you are told that some charges should be transferred from one body to another. Suppose you transfer the charge Q from body A to body B. Then charge which is left on body A will be Q1 minus Q, and charge which will be there with body B will be Q2 plus Q. R will be the distance between the charges. So the force between this system now should be maximum for some particular value of Q. To find that value of Q for which the force will be maximum. For example, if the body A had a charge say 8 coulomb and body B had a charge say 5 coulomb. Now both the bodies in totality they have a charge of 13 coulomb. Now they have some force. If I will shift 1 coulomb charge to the other body and the charges now are 7 coulomb and 6 coulomb, the force will change. I can shift charge say 0.5 coulomb more. This will be 6.5 coulomb and then 6.5 coulomb. Some of the charges is remaining same. I may shift say 0.2 coulomb, then there will be 7.8 coulomb, and on this side it will be 5.2 coulomb. Some of the charges is same. So how much charge should be shifted from one body to another so that for a fixed distance the force between those charges becomes maximum? This is the question. Now, how to solve this question? This solution to this question requires use of maximum minima theorem. Let me recall maximum minima theorem. If I have a function, suppose I have a function which is depending on x, and the graph is like this, we will present it y is equal to fx. This mathematical tool we had done in +1. This function has a maximum value at this value say x1, and it will have a minimum value at x2. Maximum value is the point as well as minimum value is the point where slope of tangent is 0. Mathematically, slope of tangent is given by the first derivative of the function. So if I differentiate the function with respect to the variable x, variable is x here, with respect to variable x, then and put it to be 0 and solve, we will get roots of x. Suppose I get root of x as x1 and x2. Then x1 and x2 are those points where function will be either maximum or minimum. Now, in order to find whether the function is maximum or minimum, we have another way. We find the second derivative of this function and find its value at first x1. If this value turns out to be negative, then it means at x equal to x1, function is maximum. And if the second derivative value had turned out to be positive, then function would have been minimum. So at x equal to x2, according to this graph, the value will be positive, and then we will be getting at x equal to x2, y is minimum. For minima, second derivative will be positive. For maxima, second derivative will be negative. This theorem you had done in +1. We'll call this theorem as maxima minima theorem. Now, let us continue with the statement, with the question. According to the question, we are to find that how much charge small q should be shifted from one body to another. Now, what is the variable here? What is the variable? Is R a variable? No, R is fixed. Is Q1 or Q2 variable? No. Variable is Q, the amount. how much charge we can shift. Like we were shifting 1 coulomb charge, 1.5 coulomb charge, 2 coulomb charge from this to this point. So Q is the variable. Let us write the force. F is equal to K. K is 1 by 4 pi epsilon naught. Q1 minus Q into Q2 plus Q by R square. This is the force. So for maximum, dF by dQ should be 0. Note that we are not differentiating with respect to R. We are differentiating with respect to variable. Variable is Q. So d by dQ, K, Q1 minus Q into Q2 plus Q by R square should be 0. Now K and R square are constant. They will come out of the derivative. Differentiation में से बाहर आ जाएंगे. And this number, it can be written as Q1 minus Q into Q2 plus Q. So this is off. Go to the other side. This product is Q1 Q2 plus Q1 Q minus Q Q2 minus Q square is equal to 0. Derivative of Q1 Q2, 0, plus let us write some steps. Derivative of Q1 Q2 plus derivative of Q1 Q minus derivative of Q Q2 minus derivative of Q square should be equal to 0. Now very clearly in this function, Q1 and Q2, they are fixed. Total charge was fixed. So derivative of a constant number is 0. Q1 is constant, Q1 comes out. And derivative of Q with respect to Q is 1. Minus Q2 is constant. Derivative of Q with respect to Q is again 1. And minus derivative of Q square is 2Q. Should be equal to 0. So this will give you Q1 minus Q2 is equal to 2Q. So Q is equal to Q1 minus Q2 by 2. So this is the charge. This much charge should be shifted from body A to body B. So we have calculated the answer to the first part. The second part, how much is the charge left with each body? So when you shift Q from A to B, the amount of charge left with A will be Q1 minus Q. Let us call that Q1 dash, that is equal to charge left with A. So Q1 dash will be equal to Q1 minus Q. So Q1 minus Q, this will be equal to Q1 minus Q will be Q1 minus Q2 by 2. So this will be equal to 2Q1 minus Q1 plus Q2 by 2. So this will be equal to Q1 dash is Q1 plus Q2 by 2. Similarly, Q2 dash will be equal to Q2 plus Q. Q2 plus Q is Q1 minus Q2 by 2. This will be Q1 plus Q2 by 2. This is Q1 dash, this is Q2 dash. So, students, with this all, we can now see that charge which should be shifted is Q1 minus Q2 by 2. And charge which is left with each body so that force between them becomes maximum is simply arithmetic mean of initial charges on two bodies. That is, both bodies should have same charge. So the example which we had taken in the beginning is, suppose one body has 8 coulomb charge, another body has say 5 coulomb of charge. Total charge was 13 coulomb, and you want to have maximum force. Then charge left with each body should be 6.5 and 6.5 coulomb each. That is 8 plus 5, by 2. That is 13 by 2 coulomb. Thank you.